This is a simple example of how the new Duct node for generative components might be used. For example, we could lay out a simple building footprint in generative components that used variables or sliders to define the X and Y dimensions of the footprint, as well as the height of the duct and the offset from the perimeter wall. Points could then be added to define the route of the ductwork. Since it is generative components, the points would be defined with an association or a relationship to the perimeter edge of the building footprint, meaning if the footprint is adjusted, the points are also adjusted. In order to use the new Duct node to create a duct that has elbows or connections, meaning it is more than just a single piece of ductwork, you first need to set auto-fitting preferences. So I'll first place a new auto-fitting preferences node onto the graph. This node defines auto-fitting preferences for the duct route by points and duct branch at point techniques. The auto-fitting preferences node has one technique, which is by default, and the initial values correspond to the current default values for mechanical auto-fitting preferences. Of course, these could be modified on the node, but I'll leave the defaults. Now I'll place the new Duct node onto the graph. The Duct node allows you to place ducts, HVAC devices, and inline devices. The Duct node has two techniques for creating ductwork. By points creates a linear duct by 2 points, so a single piece of ductwork. Route by points uses a set of points to create linear ducts and connect them with elbows. I'll select Route by Points. I'll link the points input to each of the points created earlier. And the auto-fitting preferences input to the auto-fitting preferences node just created. And a linear duct is created connecting the points. The duct size and shape and other data group properties can be set on the node properties. For instance, I could change the catalog item to a round duct, and then back to a rectangular duct, and then change the size of the duct. And now, when I change the footprint of the floor plate, the ductwork is modified to match. The Duct node could also be used to add a branch duct that maintains a relationship with the main duct. For instance, it always falls at the midpoint of the ductwork. I could add a point at the midpoint between 2 points that define one length of the duct, and a second point that defines the length of the branch duct. Then I will place another Duct node on the graph. I'll select the technique Branch at Point. I'll set the duct to branch by selecting the duct from the model. I'll link the branch point to the point that defines the midpoint, and the end point input to the other point. And finally, I'll link the auto-fitting preferences to the same auto-fitting preferences node. And the new duct branch is created. And again, if I modify the footprint, the ductwork maintains its relationships. Now let's look at a different example. This might be used in a tunnel that is following an alignment, for instance. So I have created a B-spline curve that is controlled by 4 points. Now, as we have seen, the technique for placing a route of ductwork is by points. So first I will need some points that follow the curve. So I will place a point node on the graph and set the technique to by parameter along curve. I'll link the curve to the B-spline curve and set the t value as a series that creates 10 points along the curve. Again, I will first set up the auto-fitting preferences node. Then place the duct node on the graph. This time I will select the round ductwork and set the diameter of the duct to 750 millimeters. I'll change the technique to route by points, and I'll link the points input to my series of points along the curve, and then link the auto fitting preferences. Now I can move my control points to modify the curve or alignment, and the ductwork will update to match the new curve.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.